The objective of this tutorial is to show the rules to name hydrocarbons that include alkanes, alkenes, alkynes, and aromatics according to the UPAC, and also to show how to draw structural formulas for those UPAC names. We are going to explain what the UPAC is and what it does. And also, we are going to present the definition of hydrocarbons and their main classification, depending on the types involved in the structure. UPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization not affiliated with any government. The UPAC strives to advance chemistry, in part by setting global standards for names, symbols, and units. The UPAC was formed in 1919 by scientists and academicians who recognized a need for standardization in chemistry. It's very important to have naming rules for each type of hydrocarbon because we need to have a correct procedure in what we are naming in order to name the hydrocarbon in the correct way.
What are hydrocarbons? Hydrocarbons are organic chemical compounds that consist entirely of carbon and hydrogen and range from simple molecules such as methane to polymers such as polystyrene, which consist of thousands of atoms. The ability of carbon atoms to bond strongly to each other allows them to form an almost unlimited variety of chains, rings, and other structures that form the backbones of organic molecules. Since each atom can form 4 bonds, these backbones include other elements such as hydrogen. The compounds are flammable since the two elements they contain will combine easily with oxygen in the air, releasing energy. Fossil fuels such as oil and natural gas are naturally occurring mixtures that hydrocarbons could also contain some, although it is mostly just carbon. Structure and naming conventions. The naming of hydrocarbons follows certain conventions, although in many cases, compounds may be better known under old names. In the modern system, the first part of the name represents the number of carbon atoms in molecules. In ascending sequence, the first 8 are prefixes meth, eth, prop, but, pet, ex, et, and oct. Compounds where the carbon are all joined by single bonds are known collectively as alkanes and have name ending in "ane". Therefore, the first 8 alkanes are methane, ethane, propane, butane, pentane, hexane, heptane, and octane. Classification of hydrocarbon. Alymphatics. Alkanes, alkenes, alkynes. Alkanes contain only carbon-carbon single bonds and are saturated. General formula is CnH2n plus 2. Number 2. Alkenes contain a single carbon-carbon double bond. General formula is CnH2n. Number 3. Alkynes contain a single carbon-carbon triple bond. General formula is CnH2n minus 2. Cycloalymphatics. Cycloalkanes. General formula is CnH2n. Aromatics contain benzene rings and their derivatives.
Linear alkenes, rank alkenes, and cycle
alkanes. The linear alkanes have the carbons bound together in chain-like structure, similar to a snake. The pairing alkenes are derived from linear alkenes, but instead of having just a straight change in their chemical structure, it is a branch with one or more alkyl groups. Cycle alkenes or cycloalkanes consist of hydrogen and carbon atoms bonded together with single bonds, whether the carbon atoms bound together to form a ring or a loop. Alkenes are chemical compounds that consist of carbon and hydrogen atoms, so they are also called hydrocarbons. The chemical structure of alkanes only consists of single bonds.
You pack names to name alkanes. First, you need to count the number of carbon atoms in the longest continuous chain, that is the parent chain. Then, you need to number each carbon in the parent chain. Locate the end carbon closest to a substituent group. Give all the substituent groups the lowest position numbers possible. Step number 3. Name each alkyl group substituent. Place the name of the group before the name of the parent chain. Step number 4. If the name alkyl group occurs more than once as a branch on the parent chain, use a prefix D, tri, tetra, and so on before its name to indicate how many times it appears. Then use the number of the carbon to which each is attached to indicate its position. Then step number 5 is when different alkyl groups are attached to the same parent structure, place their names in alphabetical order. And finally, write the entire name using hyphens to separate numbers from words and commas to separate numbers.
As we can see in the picture, we have 8 examples of alkanes. We have methane, ethane, propane, butane, isobutane, pentane, isopentane, and neopentane. An alkene is a type of hydrocarbons that contain a double carbon bond. Alkenes are very similar to alkanes, differing by only 2 electrons. Most alkenes are liquids at room temperature, though ethane, propane, and butane are gases. All alkenes are insoluble in water and soluble in organic solvents. In alkene, only one pair of carbon atoms will have a double bond. Atoms of any molecule are bonded together by means of a shared electron. Double bond occurs when 2 electrons are shared between atoms. In the next image, we can find that an example of an alkene, and this alkene is already named, and its name is 1,3-pentadiene. The steps to name alkenes are: number 1, locate the longest carbon chain that contains the double bond and name it according to the number of carbons with the suffix "-ene". Number 2, number the carbons of the parent chain so the double bond carbons have the lowest possible number. If the double bond is equidistant from each end, number so the first substituent has the lowest number. Write out the full name, numbering the substituent according to the their position in the chain and list them in alphabetical order. Number 4. Indicate the double bond by the number of the first alkene carbon. Number 5. If more than one double bond is present, indicate their position by using the number of the first carbon of each double bond and use the suffix -din. Number 6. Cycloalkanes are named in a similar way. Number the cycloalkene, so the double bond carbon get number 1 and 2, and the first substituent is the lowest possible number. If there is a substituent on one of the double bond carbons, it gets number 1.
Hydrocarbon containing at least one carbon triple bond between two carbon atoms. The simplest acyclic alkynes with only one triple bond and no other functional from a homologous series with the general chemical formula CnH2n2. Alkynes are traditionally known as acetylenes, although the name acetylene also refers especially to C2H2, known formally as ethene, using JPEG nomenclature. Like other hydrocarbons, alkynes are generally hydrophobic but tend to be more reactive. There are medical alkynes. A few compounds of medical interest aside from ethinyl estradiol also contain alkyne units. One example is the compounds called quinine and spermacine. Both are found in nature and have similar structure. For drawing alkynes, there are both double and triple bonds are multiply bonds. Therefore, alkynes are unsaturated hydrocarbons, just as alkenes are. To name alkynes and draw their structure follow the same rules that you use to for alkenes. The only difference is the suffix "-ine", which you use when naming alkyne compounds. Also remember to count the number of bonds for each carbon. An alkyne bond counts as 3 bonds. As you might expect, the shapes of alkanes are different from the shapes of alkanes and alkenes. A structure with a triple bond must be linear around the bond. Alkynes are similar to both alkanes and alkenes because they form an homologous series. Alkynes have the general formula of CnH2n2. So, for example, the first member of alkyne series, ethene, had the formula C2H2. The next member, propyne, had the formula C3H3. As you can see on the image, you see that the C carbon has the triple bond, so that means that it's an alkyne and that has a triple bond, and you must start from there and end with the other part. An aromatic hydrocarbon is a hydrocarbon with alternating double and single bonds between carbon atoms forming rings. The term aromatic was assigned before the physical mechanism determining aromaticity was discovered. The term was coined as such simply because many of the compounds have a sweet or pleasant odor. The configuration of 6 carbon atoms in aromatic compounds is known as benzene ring, after the simplest possible such hydrocarbon, benzene. Aromatic hydrocarbons can be monocyclic or polycyclic.
In this image, we can find 4 different examples of aromatic. The number 1 is named bromo 1 bromo 4 chlorobenzene, P or P bromochlorobenzene. Number 2 is 2-bromophenol or O-bromophenol, Number 3. 3-chloroaline, M-chloroaline. Number 4 is 3-bromotoluene or M-bromotoluene.
UPAC rules for naming aromatic compounds. If they have only one substituent, they must have the substituent plus benzene and no numbers, and also they must have common names. If it has two substituents, you need to use numbers, the lowest numbers, use prefixes ortho, meta, and para, and use common names. And if it has three or more substituents, you need to use numbers, the lowest also, and use common names. To draw structures of aromatics, you need to show the formal charges, if applicable. As a start, the benzene ring is drawn for you in each product. Also, the first step produces a mixture of isomers. The para-isomer is isolated as the sole product of interest and used in the second step. Keep only the major product for the second and third steps.
Hydrocarbon derivatives are molecular compounds of carbon and at least one other element that is not hydrogen.
As we know, hydrocarbons can have effects on the environment. They cause mainly air pollution because, for example, gasoline comes from hydrocarbons and gasoline is an environmental pollutant. But also, there are many other hydrocarbons that are pollutants. So we have to use them carefully and without damaging the world. Also, we must know that the naming of hydrocarbons is clearly important because if we make mistakes naming them, we couldn't have the correct compound to solve our daily life problems. So we need to keep in mind that and never name them in a wrong way.
Well, I learned about alkanes, alkenes, and alkanes. Well, the three of these hydrocarbons are hydrocarbons, but alkanes have just a single covalent bond, and that joining with the carbon atoms, and the formula is CnH2n plus 2. Alkenes has one or two double bonds, and the formula of these alkenes are CnH2n. Alkynes have two or more triple bonds, and the formula is CnH2n minus 2. Therefore, 4 hydrogen atoms less than the corresponding alkane.
Hydrocarbons are related with pollution because they can produce gasoline and diesel, which are pollutants to the environment, and this causes that the air breathed isn't clear anymore. Also, sky looks contaminated when we see it, and many other effects. Also, it's very important to name the hydrocarbons correctly because they are useful in daily life problems, and if we don't name it correctly, we couldn't solve anything because we don't have the correct compound to do it.
I think it's important for us to know about these things because the some material that you use on our daily life are made of hydrocarbons and we need to know about them and take care of them.